use the square root property to solve x plus 2 quantity squared equals 5. Now this looks a little bit more complicated than the problems we've been looking at previously, but we still have a quantity squared equals a number, and we're still able to take the square root of both sides using the square root property. On the left-hand side, if we take the square root of x plus 2 squared, we're left with x plus 2. Because squaring something and then taking the square root cancel each other out. Those are actually referred to as inverse operations, but usually I just tell my students that they're reverse operations. They undo each other. So on the left-hand side, we have x plus 2. And then on the right-hand side, we've got plus or minus. Now the square root of 5 we'll just write as root 5. So we have applied the square root property, but we're not finished yet. We still need to get x alone. Now to do that, we need to subtract 2 on both sides. So we're going to be left with x on the left. And on the right, when we perform arithmetic when something has a plus or minus symbol, usually we put everything else first, and then we put the term with the plus or minus at the end. So we've got the negative 2 that's going to go first, and that's not a plus or minus 2. We know that we have a negative 2 there, so that's definitely negative, negative 2. And then we have the plus or minus root 5. And now that we have x alone, this is our final answer. We've got x equals negative 2 plus or minus 5. Now, this refers to two different solutions. Whenever we have a plus or minus, that gives us two different things. So one solution is x equals negative 2 plus the square root of 5. Or x could be the other solution, negative 2 minus the square root of 5. So this is another way to write out the two solutions. And for people who aren't really comfortable with the plus or minus symbol, this might be a little bit nicer because we can see the two solutions separated out. And if we wanted to get a decimal approximation, we could enter these into calculators. We could take negative 2 plus the square root of 5 and negative 2 minus the square root of 5. We would get decimal approximations. Sometimes students like to do that just so that they can get an actual idea of what these solutions are approximately equal to, because it's difficult sometimes for our brain to think about what a square root of a number is and then adding or subtracting another number. For most intents and purposes, x equals negative 2 plus or minus root 5 is fine, but you might want to play around with these and enter them into a calculator just to get an idea of where the solutions might fall on the number line.